Hello everybody, this is Professor Lombardo. This week we're going to be talking about hypothesis testing, and particularly today we're going to explore the main idea behind hypothesis testing for claims about a population mean. It's important to contrast hypothesis testing to confidence intervals. The approach is very different. In confidence intervals, we kind of admit that we have no idea what the population mean is going to be, and so we use a sample to try to estimate it with saying we'll have a certain amount of confidence that the true population mean falls in this range. With hypothesis testing, we kind of go about it a little bit differently. In this case, we think about a claim about the population mean, and what we fundamentally try to do using the data is determine whether or not this claim is true or false. When working with hypothesis testing, we consider two different hypotheses. We'll have a null hypothesis, and this is going to be a value that we claim about the population mean, and we're testing this. And we have an alternative hypothesis, and this is just going to be an alternative claim to the null hypothesis. So let's consider a quick example. Maybe we're testing this claim here. The mean expense for a sales dinner is $1,300 or less. Our null hypothesis, which we usually pair off with wherever we get equality, is going to be that our population mean, or the mean expense for all sales dinners in this case, is less than or equal to 1,300. Now the alternative to that is that the actual mean for the sales dinners is greater than 1,300. It's the convention in hypothesis testing that our null hypothesis is the thing we believe is false. And typically our approach in hypothesis testing is to set that null hypothesis and then use a simple random sample from the population to provide evidence against that null hypothesis. So remember what we're doing here, the null hypothesis is actually the claim that we tend to think is false. And we're trying to use sample data to give it evidence for the alternative hypothesis, which is equivalent to saying it's evidence against the null hypothesis. Let's take a look at some of the null and the alternative hypotheses and some R simulations to see how hypothesis testing might actually work. Okay, so here we have a simulator. Off in the right panel here, we have in the green dots the actual population. So typically when we're doing hypothesis testing, we don't actually know this kind of information. So this is more of a thought experiment. So the way that a hypothesis test works is somebody makes a claim about the population mean. So maybe I make a claim that the true population mean is maybe something like 107. And so what I can do with this slider here is set any null hypothesis, or in other words, I can make any old claim that I want. So I'm going to say my null hypothesis is that the mean in the actual population is equal to 107. So this is what I have on the left here is what some people might call the null population. This would be kind of a version of the actual population where the null hypothesis, what I'm claiming, is actually true. Now we can see right away that there's going to be a disparity between my claim, which is the null population, and what's actually happening, which is the actual population. So here's how hypothesis testing might work. If we make an assumption that the null hypothesis is true, or that we're working with something called like the null population, we can actually generate a sampling distribution that would hold under that assumption. And that's what our next little worksheet does here. Here's our null population. So this is assuming that the null hypothesis is true. This is what our population would look like. And we have the usual generator. We can pick our sample size. I'm going to pick a sample size of 20. And we can start gathering a bunch of different samples and computing their sample means. And as you might expect, once you've collected enough samples, what we end up with down here is a nice normal distribution. All right, this is the sampling distribution for that null population. Now, what happens here, ahead of time, we figured out that our null population, we can see, is not going to be the same as our actual population. These means are different. I believe in the actual population, the mean's about 100, and we set our null hypothesis to be 107. So what happens is if we compare the actual population sampling distribution to the one that we get from the null population, right, red versus green, all based on this fixed sample size of 20, you can see that when our null hypothesis is off, these two distributions, these sample mean distributions for the actual case in green and for our null hypothesis assumption in red, they don't overlap too much. They might overlap a little bit, but loosely speaking, If we went out and actually grabbed data from the real world, we would be getting sample means as determined by this green histogram, because this is our actual population. So when we go out in the real world and grab a sample mean, the most likely sample mean values are going to be down here. But we, playing this thought experiment of let's assume the null hypothesis is true, would see that getting a sample mean down in this green region would be kind of unusual for the null hypothesis sampling distribution that we would generate, assuming the null hypothesis is true. So what happens here is what we get from our sample data doesn't seem to match the theoretical sampling distribution that we should get if our null hypothesis were true. In other words, the sample data looks unusual or improbable based on this thought experiment of what would the sample means look like if the null hypothesis were true. Now, we can reset this and think about, well, what if I guessed correctly? What if I set my null hypothesis to be equal to what's in the actual population? What if I actually guess the right claim and use that as my null hypothesis? Well, again, generating a sampling distribution. So now I've collected about 1,100 total samples. What you can see is when you correctly guess the actual population, the sampling distribution in red and green, now they're essentially overlapping. So when I go out and collect a real sample mean from the actual data, right? Remember, the green histogram dictates that. It's going to fall right in the middle of my theoretical null sampling distribution. So it won't appear as kind of an unusual sample given that assumption. And this is the main idea behind hypothesis testing. When there's discord, when there's a difference between the null hypothesis and the actual population, which we can't see, what we're going to get is a sample mean that when we go out and grab real data, we'll get a sample mean that looks unusual based on what we'll call the null sampling distribution. And if they're the same, we'll get a sample mean from the real data that doesn't seem that improbable based on our null distribution. So this is how we use probability to kind of generate a hypothesis testing approach. I'm hoping there are some Law and Order fans out there, because a very useful analogy for hypothesis testing is actually the criminal justice system. The main idea here is as follows, or I should say the connections are as follows. The presumption of innocence, or innocent until proven guilty as we know it, is sort of the idea behind let's assume that the null hypothesis is true and kind of follow this to the logical end. What we're doing as hypothesis testers, right, as our researchers, we're playing the role of the prosecution, and what we want to do is prove beyond a reasonable doubt that the defendant is guilty. In other words, we want to prove beyond a reasonable doubt the null hypothesis is actually false. So again, we're returning to this idea of the null hypothesis is what we're trying to disprove typically. What we're going to do is hope to use our sample to show beyond a reasonable doubt that we should reject the null hypothesis, or that the null hypothesis is actually false. Now, the critical phrase here becomes beyond a reasonable doubt. How do we know when we've presented enough evidence that we should say, the null hypothesis can't be true? Look how different the actual sample mean is from the sampling distribution that we've, in theory, would have, our null distribution. So this is the fundamental question in hypothesis testing that we need to answer. How can a sample tell us our null hypothesis is false beyond a reasonable doubt? We need to quantify that. We need to make that more concrete.